Hello everyone and welcome back to my YouTube channel. So today we are starting a brand new series on biostatistics. Now I know what you are thinking. When most students hear the word biostatistics, they immediately feel anxious. They think about complicated formulas, confusing numbers, and difficult exams. But here is what I want you to know. From the very beginning, biostatistics is not difficult. It has just never been explained to you in a simple way. And that's what exactly this channel is here for. But before we start, subscribe to my YouTube channel and turn on your notification bell. So your subscription helps me to continue creating educational content for students, for health professionals like you. But what is biostatistics? Let me break the word down first. So bio means life or living things. Statistics means the science of correcting, analyzing, and interpreting data. So when you put them together, biostatistics means using data and numbers to understand and solve health problems. But let me make it even simpler. Every single day, doctors, nurses, and public health professionals face questions like, does this drug actually work? Is this community at risk of an outbreak? Are women more affected by diseases than men? Is this new vaccine safe? So these are not just questions you can answer by just looking at patients. You need evidence, you need proof. And the tools that gives you the proof is biostatistics. So think of biostatistics as the science behind healthcare decisions. So without it, we are just guessing. So with it, we can prove things with confidence. But why does biostatistics matter? So let me bring this to life with real examples that you can relate to. So imagine a doctor in Lusaka has two malaria drugs, drug A and drug B. So she noticed that the patients on drug A seems to recover faster. But is this really true or is just a coincidence? So now how does she prove to the Minister of Health that drug A is better? So she uses biostatistics to compare the two groups scientifically and get a definitive answer. So imagine there is a cholera outbreak in a township. Then the environmental health officer suspects it's coming from a contaminated water source. But suspecting is not enough. He needs to prove which water source is causing the outbreak. So that action can be taken immediately. How does he prove it? Biostatistics. So whether you are a doctor or a nurse, a clinical officer, or a public health professional, biostatistics is not just an exam subject. It is a skill you will use for the rest of your career to make decisions that affect people's lives. Let's now talk about the three areas of biostatistics. So biostatistics has three main areas, and I want you to understand all the three because your exam will cover all of them. So the first one is what we call descriptive statistics. So this is where we describe and summarize data. So when we gather information from patients or a community, the first thing to do is to organize it and summarize it so that it makes sense. So for example, when you gather measurements from 500 patients, you cannot just look at the 500 numbers and understand anything. So you calculate the average weight, you draw a graph, you organize the data into a table. That is descriptive statistics. So think of descriptive statistics as taking a photograph of your data. You are capturing exactly what is there. So the second area is probability. So this area is about chance and uncertainty. So in health, nothing is 100% certain. So we use probability to quantify our uncertainty. So for example, what is the probability that a patient who smokes will develop lung cancer? What is the likelihood that this test result is not correct? What are the chances of the disease spreading to the next village? So think of probability like weather forecasting. The meteorologist doesn't know if we'll have sunlight tomorrow, but she can say there is a 70% chance of having sunlight based on patterns. So that is probability. So the last area is the most important one, and the one that is tested mostly in your exams. So this is where we use small groups of people to make conclusions about a large group. So here is a simple example. You want to know the average blood pressure of all adults in Zambia. You cannot measure every single adult in Zambia. That is impossible. That will take years and cost millions. So instead, you randomly select 1,000 adults and measure their blood pressure, and use those results to make conclusions about all adults in Zambia. So I want you to think of these statistics like tasting soup. When your mother is cooking, she does not drink the entire pot to know if it tastes good. So she takes one small spoon from the pot, and from that one spoon, she knows whether the whole pot needs more salt. So that is what exactly this statistics does. So these three areas work together, and in this series, we are going to master all of them step by step. So there are a few terms that you should know. So let me quickly introduce 4 key terms that will come up again and again throughout this series. So your lecturers love testing this, so write them down. So the first one is population. So the population is all about the people or things you are interested in studying. For example, all students at a medical school, all pregnant women in Zambia. The second term is sample. So the sample is the small group you actually study. Because you can never study an entire population, you select a manageable sample from it. For example, instead of you studying all 10,000 medical students in Zambia, you study 500 of them. The next term is parameter. So a parameter is a number that describes the population. For example, the true average blood pressure of all adults in Zambia. So because we can never study everyone, we almost never know the true parameter. The last term is statistic. So a statistic is a number that describes your sample. For example, the average blood pressure of the 1,000 adults you studied. So we use statistics to estimate parameters. Now here is a quick exam tip. If your lecturer asks you to define a parameter or what is a statistic, many students mix these two up. So just remember, parameter is equal to population. Statistics is equal to sample. So both start with the same letter to help you remember. And that was your introduction to biostatistics. So we've covered what it is, why it matters, the 3 main areas, and the key terms you need to know. So from the next video, we start diving deep into each topic, and I will be using new exam questions from the actual past papers to show you exactly how your lecturers test this concept. So make sure you do not miss any video in this series. Now, if you feel like you need more personalized help, whether you are preparing for an upcoming exam, struggling with a specific topic, or you just want one-on-one guidance, I offer personal online and physical tutorials. Just drop me a message on WhatsApp and you will find my number in the comment section below. So before you go, like this video if it was helpful, subscribe and turn on notifications so you never miss a video. Comment below and tell me which biostatistics topic scares you the most. Share this video with your classmates who are struggling with biostatistics. And remember, biostatistics is not difficult, and I will see you in the next video.